In this case, what we've got is a hydrated sample of sodium thiosulfate, and we've been told that its mass is 8.54 grams, right? And what we need to do is effectively work out the value of x, right? And so what does x mean? X is effectively, well, for every 1 mole of Na₂S₂O₃, how many moles of H2O are we going to have? And of course, this leans more into amounts of substance, but what we've been given are masses, right? And so what we need to do is convert some of the relevant masses to moles, right? And so how can we do that? Well, the equation I'm going to use is the equation that relates moles, mass, and molar mass, right? So which is N, number of moles, is equal to the mass divided by the molar mass, mR, okay? And what are the relevant amounts of substance? In this case, the amount of substance of the Na₂S₂O₃ and the amount of substance of the H2O. So I'm going to first work on solving, well, what's the amount of substance, what's the number of moles for the Na₂S₂O₃? And for that, the most relevant mass is the anhydrous sample mass, which is effectively the mass when the water's been removed. So what I can say is that the number of moles of Na₂S₂O₃ is equal to 5.66 divided by, well, I'm going to need to work out the molar mass of Na₂S₂O₃ to progress. So if I say mR of Na₂S₂O₃, so I do need to work that out. If we refer to the periodic table, you see some of the relevant relative atomic masses, right? So sodium would be relevant, sulfur would be relevant, and oxygen as well, right? And so if you work that out, that's effectively sodium is 23 multiplied by its occurrence, which is 2, plus sulfur, which is 32.1 multiplied by its occurrence, which is 2, right? So S2, plus the oxygen, which the relative atomic mass is 16, multiplied by its occurrence, which is 3, right? And this is going to give us a relative, well, a molar mass. It's going to give us a molar mass of, well, if you work that out, you should be able to find out what that is. But that's going to be 158.2, okay? And the units of that, given it's a molar mass, is going to be grams per mole, right? So using that value, 158.2, we can now work out the number of moles for Na₂S₂O₃ in this particular 5.66 gram sample, right? And if you do have a go at working it out, what you should find is you get 0.03577, right? Okay, and that's going to be in moles, right? Now, we also need to work out the number of moles of H2O, but if you look in the question, we're not actually explicitly given like the mass of the H2O is X or what, but what we do have is the two different masses, the hydrated mass and the anhydrous mass. So, of course, we can work out the mass of the H2O by simply subtracting the mass of the sample not containing H2O. We subtract that from the mass that does contain H2O, because of course the difference is made up by the H2O, right? So that would be 8.54 minus 5.66, right? So if you do work that out, what you should find is that gives you 2.88, right? And that's going to be in grams. And so what we can say now is, okay, well, the number of moles of H2O is equal to 2.88 divided by, and so now we need the relative, well, we need the molar mass of H2O, right? So so MR of H2O, you may already be aware of what that is, but so that's H, yes, that's going to be 1 times 2, and the occurrence for oxygen is just 1, so it's going to be plus 16, which is going to give you 18, and then that, in terms of units, that's going to be grams per mole, right? Right, so I'm going to have 18 here, and so the number of moles in this case is going to be it's going to be 0.16, right? And that's going to be in units of moles. So now we have the number of moles for the Na₂S₂O₃ and that of the H2O. As you can see here, we've got Na2. Yeah, so Na₂S₂O₃, you can see it's on the left hand side. So what I'm going to do is put together a effectively a molar ratio comparison, and I'm going to kind of keep to that same convention, right? So I'm going to keep that on the left hand side. So I'm going to say number of moles of Na₂S₂O₃ compared to the number of moles of H2O, right? And so we're going to have 0.035777 and 0.16, right? And so if we recall, really what X is a question of, for every 1 mole of Na₂S₂O₃, how many moles of H2O. So I really do want to get the moles of Na₂S₂O₃ in this ratio to be 1, right? So to help me to answer that question. So in order to get this to be 1, I'm going to divide it by itself, right? That would be a straightforward way to do it. So 0.035777, and so that gives me 1 on this side. What I'm going to do is, because we've done that on the left hand side, because this is a ratio, effectively functions like how an equation would, we do need to do the same on the right hand side, right? So 0.03577, right? So, and if we go through that process, you should find that you get 4.4721. All right. Okay, now what I'm going to do at this stage is consider that, well, X actually does need to be an integer value, right? And so I'm going to need to round the value that I've got for H2O to the nearest integer value, right? In this case, even though it's quite borderline, it does ultimately round to 4, right? So in this case would be 1 ratio of what's approximately 4, okay? And therefore we can say that X is equal to 4, right? And if that being the case, therefore our equation is going to be Na₂S₂O₃ and then 4H2O, okay? And yeah, so that, I mean, in this case, that's how you'd work it out. And I'm just going to add that number as we kind of requested in the question. I'm going to add it here. So I'm just going to put 4 here, right? Okay.